Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar, MTI Wireless Edge. Today's host is Ofer Bismuth. He is our contact person there at MTI Wireless Edge. He's the Director of Sales and Marketing for North America. If anyone has any questions, please feel free to submit them in the question box, and I'll read them off to Ofer, and he'll answer them at the end of today's presentation. Ofer, thank you so very much for being with us today and sharing your information with us. I am finished for now. Please go ahead and take it on over.
Hey, good morning, everyone. As mentioned, my name is Ofer from MTI. MTI, it's an antenna vendor for 45 years, but let's start first of all with the agenda. We will talk about starving for capacity, why there is a more need that I'm sure that everyone understand and see this, but we can see the result of what is the application. We will do a short introduction about MTI, everything that's on the web, so it's very easy to find our product. And of course, you can go to Microcom website and find our portfolio. We'll talk about a little bit about antenna solution. Most important part of my presentation will be the consideration of antenna selection, which is very critical for everyone to answer and get answer for this kind of solution. And we will have open question, discussion, and summary. Okay, so the question is, what kind of demand for capacity you want? Either you want a good network or you want a slowly network, which means that the reason for this that there is a huge starving for capacity, huge. We will see that the reason for this, first of all, there is a lot of application today. Everyone understand that today a lot of application, social application. Now there is a lot of Facebook Live, WhatsApp, video call. There is a lot of live streaming, video sharing. A lot of application require more and more demand for capacity. On the other side, you have a lot of location which need a lot of traffic. So maybe the architecture or the equipment today is good enough, but it's not good enough for the future. So you need to build for some time in the stadium, for example. You build for pickup, not for the peak time, not for the everyday traffic. So this is also something that you need to know about this. And also there is a lot of demand, and we saw that today everyone talking about 8x8 MIMO, and so something like that. Today it's by far it's 2x2 and 4x4, but we saw more and more now moving to 8x8. Some of them are LTE, but some of them are also a new product. We will talk about this. When the bottom line that I try to say everyone that everything leads to a better antenna technology. Okay, you need to understand that it might be that you have an excellent radio. Okay, but having a poor antenna solution will let's say at least will affect all the network. So because the antenna is kind of the eye and the nose of the radio, and you need a good antenna in order to provide a better capacity. So there is also a technology moving very fast. We talk about F2 today, but we have also 11 AD today. A lot of people are moving also to E-band, V-band, 60 and 80 gigahertz. We saw more and more antennas technology smart. There is a company like Rodwin, like Cambion, Ubiquiti. A lot of people are moving more and more to smart antenna technology. The main idea that I think it's coming from competition to fixed LTE, because the LTE is the main idea that it can give you more capacity you know how to play with the technology of the antenna. So everyone trying to compete with fixed LTE. And I know that in the US you see more and more fixed LTE, which means that taking the technology of LTE and using this for broadband, not for mobility. So we see how much capacity you got in moving forward with the technology. But again, there is now the 11AD. I think we will see more and more in 18, or maybe next year we'll see more company radio vendor moving to AD. So as I mentioned before, there is a lot of capacity, there is a lot of demand, and the idea how you make a better technology antenna on the same footprint. You don't want to take a big shelf and put a lot of radio and antenna. So the main idea is how you're going to use the same space for higher density of antenna, but also to make it much better, because we will see when we talk about antenna consideration, we'll see that that each antenna have their own let's say parameter, and you need also to handle a lot of radio in the same location. So it's also as I mentioned, the antenna is the eye and the nose of the radio, and it's very important to take a better antenna technology in order to support much density area radio. So smart antenna in general, the main idea of trying to move to smart antenna, it's better coverage and capacity to maximize the gain to desired direction. It means that if you have a customer somewhere, you can give him the maximum capacity if the other one doesn't need it or something like that. Improve the link quality and decrease the interference between antenna, because you can play with the volume or with the gain of the antenna or with direction. The main idea that you have kind of in smart antenna in general, you have kind of different element, and you have a control unit that you can play and change the direction, the gain, and sometimes the beam width you can change. So it's kind of a smart antenna that it's stupid antenna, yeah, but you have a kind of active component that change or choose a different element per scenario. Okay, and everything controlled, by the way, by the radio, because the radio got in the interface. So we have some, let's say, different approach. Okay, you have the simple basic, which called beamforming, that you change the beam width according to to the customer, but it's very simple because you don't feel the customer. The other one, it's called dynamically phase array, which means that you have always interaction with the customer, so where is the customer, where is the signal, so you can change the algorithm in order to support the specific customer, or you change again the radio. It's more dynamically changed let's say the signal through the customer. Again, if you look on MTI portfolio, you have a lot of kind of different solution. It can be whatever we will talk about, this VNH polarization, vertical, horizontal, or dual slant, or it can be directional CPE or sector antenna. So you have, again, MTI have a lot of portfolio of different kind of solution. This is, by the way, VNH, which means that the technology, and this is the dual slant. The dual slant coming from the mobile. So the assumption is that dual slant can support a better let's say a better solution for mobility. But again, it doesn't say anything. The same parameter, interference, side lobe, everything is the same for dual slant and VNH. But more and more technology, for example, most of the LTE now in the market are looking for dual slant. You see company like Cambion, they have either some technology, they have some radio, they have dual slant, some radio, they have VNH. So it's not, it's not that, everyone moving to dual slant. So you can see both of them. But again, the same idea, the same things for both of, the polarization. But it's very important to mention, if you have a CPE directional antenna, it can be either VNH or dual slant. The main idea that if it's VNH, you can rotate it by 45 and get dual slant. This this let's say technique cannot be done in the sector antenna. Okay, so this is the reason that the sector is fixed. Okay, and the directional, the CP or the customer side can be changed either both of sides. Of course, you can see more triple in different kind of frequency. Here it's 5.8 frequency. For example, it's dual slant V and V polarization. You can see 4x4, which means that you have in 4x4 you must have some separation between the streaming. So in order to give a separation and less interference, so the main idea you play with the polarization, and we will talk about this about antenna consideration. So here you can see dual slant with dual polarization, so you have 4 streaming. I will be back to technology, but few words about MTI, please. First of all, MTI is over 45 years. We started like a military antenna vendor, and then we moved to broadband, and now we have also a lot of RFID technology also, which also getting more and more famous. I'm not sure if you read about the Amazon supermarket. So they have all the network there. It's RFID. Everything is controlled kind of wireless and RFID. So you take a product, it's RFID. So it's the technology. It's the potential of RFID. It's huge, but of course the price. But again, it's a different market. RFID from broadband, it's 2 different market. This is application like all the application you have in the mobile, and this is more like giving a service of broadband. MTI in the market, okay, we position our product, okay, and our process. It's not only product, it's all the QA. It's to give you high quality antenna, and we will talk about this. But when we say quality or high quality, it's mean performance. So this is something that you need to know. Again, the antenna can give you a better performance on your network, or to give you a poor performance. Okay, we will see this by case study. So very important to mention that to choose the antenna, it's one of your critical steps in order to get a better performance network. And the funny thing, if you check what is the cost of the antenna, partial of your network, you will see it's less than 5%. So it's not a huge amount of money in order to choose the better antenna. And MTI, it's one of the best in OEM market. You would see we have, you name it, we are there in the antenna. Either it's integrated or embedded or whatever. You will see that we have a lot of OEM in a lot of radio vendor like Radwin, Redline, Cambion, Aruba, and so on. So we have, as I mentioned, we have 2 different business. One is the defense market. We have a lot of, airborne. We have a lot of submarine. Huge amount of project, unbelievable. I don't want to talk about it, but a lot of projects in the military, either in Israel or worldwide. A lot of companies are also doing a lot of job outside Israel. In the commercial market, we have either the wireless application, which is the broadband, and RFID. Our antenna can be used for any of point-to-point, point-to-multipoint. In point-to-point, it's very tricky because you can use the E-band or V-band for point-to-point, but also you can use the iGain 2-foot for point-to-point or the dish antenna. But Again, we don't support a dish for 2 foot, 3 foot, 4 foot, and so on. But again, it's tricky because it depends which range or link budget you want to work with. Point to multi-point, of course, there is a lot of portfolio. We also support a lot of LTE spectrum, the 2.5, 3.65, even the 5.1. A lot of wireless application, from trackside, mobility, LTE, and also small cell backhaul, which we use the E-band and V-band mostly. In general, antenna structure, just for your background, there is the radome, which is kind of plastic, but a specific plastic. It can change a lot the performance, so it's not a regular plastic. Okay, it's a kind of material that built for antenna. You have the gasket, which give you IP67. It means that all the water tightness and dust and everything. And you have also in the other side you have the metal, which is we call it the ground, which focus the radio or transmission and on the forward. Of course, the connector, it depends if you have 2 connector, 3 connector, 4 connector, and in the middle you have the PCB. Okay, the PCB, this is the antenna, which also designed carefully in order to give you the most performance, and it can be 1 PCB, 2 PCB, or even 3, sometimes 3 or 4. But again, this is the main idea. The radome, the ground, and the middle is the PCB. It can be also a different kind of metal inside in order to control the shape of the antenna. So what is the product solution that we give? We give all the frequency from 700 up to 80 gigahertz and 60 gigahertz. You can see all the portfolio. We give base station, CPE, subscriber, Omni, kind of enclosure, a lot of mounting kit. You can see a lot of mounting kit in the market that people are using our mounting kit like, for their equipment. In the dish portfolio, we have a very small amount of, very limited, I can say. We have a 2-foot parabolic dish antenna for 3.65 and 5.8. And the E-band, we have also 80 gigahertz, and the V-band, we have 60 gigahertz. So we have kind of portfolio, but again, it's and by the way, the E-band, V-band cannot be used for like off the shelf, because you must use the radio vendor directly. It's not like the other stuff that you can use a cable. We have also kind of integrated solution for enclosure. It's very good for company that need to do a lot of, let's say, integrated solution. They want to use a box, which the antenna give you IP67. Inside the box or inside the enclosure, you can put a lot of radio equipment. Some of them put in. They took, for example, a MikroTik. They put inside. They took Ubiquity, which is indoor. They put inside. A lot of solution that you can use. The main idea that you have a box with variety of antenna, and you can use it for like your radio. Okay, it's give you a good solution for carrier grade IP67. This is also another solution for the enclosure. The main idea here, it's already, if you can see, the bottom and the top, you have a lot of option to put a cable, connector, Omni antenna. Inside you have a lot of very easy installation side, so you can use a screw in order to put your PCB inside. So it's very, very, or the radio, it's very flexible solution. We sell a lot of these for, by the way, RFID also sell a lot of these because the application. So the first question I always hear is how much it cost me, and this is really a wrong question. I will explain to you why, because now we are going to a little bit technical. Okay, not so much, but try to understand why it's a wrong question. So first a question that I ask you, how much it costs you to install? Look, how much the installation, and you know how much it's going to cost you to install it on the roof, or on the pole, or whatever, somewhere in the tower, and you know how much is expensive the tower. So a lot of, I don't want to say thousand, but to install antenna today, it depends on, of course, when you're going to install it, but it's a very expensive, let's say, process, okay, to install the antenna. So the question is, how much is going to how much it's going to cost you to reinstall the antenna in case you choose the wrong antenna, okay? Assuming that the difference between MTI antenna, which is the kind of quality antenna, to other antenna, it's about, I don't know, 10% or even 15, 15%. So how much it will cost you to reinstall the antenna again after 1 year or after 6 months? And there is a lot of cases that we saw that people install antenna, they have a problem, they switch to MTI, and everything was fixed. By the way, MTI, because MTI know the quality of our product, we give 3 years warranty for each antenna. So you have 3 years warranty, outdoor equipment, full outdoor equipment, outside, from the performance and everything. So in order to give you, let's say, tools in order to choose the right antenna, we will talk about a few parameters when you, each antenna, each spec that you will see must have this kind of solution. Sorry, this kind of parameter. Otherwise, you can ask and you can compare, okay? So first of all, it's very easy. The frequency is very clear. What is the frequency? And, the antenna need to be designed to support this frequency. Sometimes you need a beamwidth frequency, from 4.9 up to 6.4. But in the US, there is some kind of different frequency. Most of the antenna today, I can tell you that in the 5.8, working from 4.9 up to 6.1. In 3.65, they need to support, by the way, the new frequency band that's going to be from 3.5 up to 3.7, 2.4. Now there is also the LTE, so you have also 3.3, 3.5, 3. And sometimes even 3.7. So again, the frequency is very easy to read. It's very clear. And we'll see about, again, the gain. It's also very clear, of course. In gain, you need to ask if it's a typical or maximum or minimum. Mostly MTI give you the minimum. So if you do a network design, you know that it's a minimum, at least a minimum, but sometimes it can be, other vendors, sometimes you can see typical, you can see maximum. They play with the gain. Of course, the gain can change over the frequency. So it's very important to understand that if you go over the frequency, what is the minimum gain? And we will talk about few of the parameters. So if you look about the parameter, of course, there's the beamwidth. Sorry about this. The beamwidth is if it's specific, good for the sector, but although the beamwidth is also for the CPE, most of the CPE, in order to get the maximum gain, they have a very narrow beamwidth, 5%, 7%, or 11 sometimes. But the beamwidth mostly is very important in the sector. If it's 90 degree, 60 degree, or in the dual slant you have 65, 90 degree. So it depends on the sector. We will talk about this. And first of all, let's see the front to back ratio. Okay, the front to back ratio. Wait a minute, I need to see that. Okay, sorry. Okay, let me start with the side lobe. I'm sorry. The side lobe is very critical for interference. It's side effect of the design. Okay, it means that there is most of the antenna have side lobe. Again, the level of the side lobe is very critical. The side lobe means that it's not the main lobe. You have a lot of small lobes which are not the main, and you need to decrease them, because in order there is also interference from other antenna, interference to the environment, a lot of problem with if you want to point sector to the customer. So there is a standard for the side lobe. Okay, the lower of the side lobe, the better is the performance. I mean that you don't have a lot of interference from outside. Your antenna, it's perfect from performance and design. So this is something that you need to compare. Okay, what is the side lobe? Okay, and also there is another parameter which also kind of lobe. It's the front. Okay, there is the back side. Okay, always you have a back lobe, which means that the antenna transmit in the front, but you always have in the back side. Why it's very important? If you want to do, a tower, you want to cover a cell, 360. So always in the backside of the antenna, it's also sensitive because it's antenna. So you get a lot of noise in the back. So if you want to get a lower interference or better performance, you need to decrease the backside lobe. Okay, and this is called, in general, you can see this in most of the antenna parameter. It's called F2B ratio, or front to back ratio. It means that the higher the ratio, the better is the performance. Okay, it means that the antenna need to be designed that the back ratio must be the lower. If you look in, for example, in Cambion, it's going to be minus 35, sorry, or even minus 40 between the front and the back. It's very critical to check this parameter. Okay, again, you need to compare when you take two antenna. You need to compare what is the parameter which is critical for the antenna. Again, try to understand that when you put antenna on the roof or in tower or in pole, it's always it's not the only antenna in the area. Okay, you have a lot of interference even from other antennas, so you need to to be sure that when you install the antenna, you don't need to run and again and do installation and again and redesign and a lot of troubleshooting. So this is the main idea. And again, it's not only interference, it's also cell capacity, because if you have interference, so you cannot do frequency reuse. So everything is performance, which means you need to choose a good quality antenna. And this is something that I can show you after that a few case study. So we talk about the side lobe. Sorry about this. Cross pole. We talk about cross pole port-to-port isolation. This is two different issues. Port-to-port isolation is kind of physical. Okay, and when you design the antenna. And cross pole, it means that if you remember, we talk about VNH and dual slot plus minus 45 degree. So in order to keep a better solution, if you have 4 streaming or 2 streaming, you need also to have a better cross polarization parameter between the two streaming. So again, it's also critical. It's again, the interference can come from outside if you have a bad vertical horizontal from in your antenna, and someone else it's transmitted in H polarity or V polarity, and the antenna it's not good enough, so you have interference from outside. Again, it's a very critical parameter for. And by the way, you are using these also for cell capacity in order to do a reuse of frequency. Again, all the parameters are very critical for you to at least to check, to ask questions, to compare, by the way. And you will see the difference. It's not so much in price, but in performance, it's going to be critical. Going forward, okay, we talk about all the parameters of the antenna. By default, the antenna it's a full outdoor solution. It means that it must be snow, wind, dust, rain, temperature, everything. It's outdoor. Okay, so that's what I said, that we promise you, or we guarantee at least 3 years warranty for our antenna. And you can see all the environment condition from temperature, from minus 40 to 71, vibration, shock. It's try to imagine that you send the antenna and it fell from the truck. Okay, 1 meter, 2 meters. So there is a lot of mechanical shock, vibration, humidity, and dust and everything. So Again, everything is on the spec of the antenna, okay? And all the spec, by the way, of MTI and the test result and everything, you can find it on our website. By the way, we just to clarify, we also do a 100% VSWR test, which means that each antenna at least tests by VSWR, which give us, and this is also it's documented for each antenna by serial number. Each antenna, by the way, has serial number, and the main idea is to be sure that when we ship out antenna, it's 100% tested. So what's happened if you choose the wrong antenna, okay? And this is a real network design that someone is doing, and you can see that the coverage it's much better with a good antenna. We can speak about a lot of what's happened if you don't choose the good antenna, what's happened if you go the wrong antenna, okay? Coverage, which can be bad, throughput, not mention the overhead that you need to do about reinstallation, troubleshooting, time consuming. Customer, in the end of the day, customer is paying for service, so the customer is critical, and not mention the ROI that you need to put in order to make the same coverage, the capacity. You need to put more antenna, more cells. And again, this is something I can put, by the way, a lot of other results of this kind. And this is a solution that we've done with the customer. To be honest, it's a Cambion customer that are using the specific antenna from their portfolio, but this is in the left side, okay, and you can see the default antenna that the customer is using. And when he switched to MTI, it got much. You can see the green area. It can get much better capacity, much better coverage, much better. You see a lot of area that you don't get services. You can see the coverage, the different. This is a real network. You took 60-degree antenna, you replace it by another 60, a different 60-degree antenna from MTI, and boom, you get a lot of different in network. That's it. This is a real network, by the way. They still buy most of the MTI, let's say most of the antenna from MTI. Now, there's a new, Cambion moving outside with kind of smart antenna. But again, most of their antenna today are from MTI, and they are a huge wisp in the US. But again, the main idea that I want to show you the difference. You can see the picture. It's very clear to see that capacity is better, coverage is better. Try to understand how much less antenna do you need, or how much less, let's say, cells do you need. It gives you much better, service for higher capacity, increase the number of customer per area. Unbelievable solution. And this is, by the way, a real network that we have done with the customer. And we are talking about one cell. Try to imagine hundreds of cells over the US. So the real question, how much it costs, you understand that it's not the real question. The question is what kind of performance you want to get, what kind of quality, what is ROI. I need to put 2 cells, I can put 4 cells. In the same cells, I can put 6-sector or 4-sector. Again, because the interference, side low, front to back ratio, we mentioned about cross polarization between streaming. So this is a real, and how much it costs to use a tower, and how much it costs you money to make all the power, everything, and the radio. So once you acquire a tower, let's say, a pole, or install it, you want to use the same radio, the same equipment for more capacity, for more coverage, because this is the ROI for you, okay? And again, the cost benefit, you need to check it every time. So to summarize, just give you idea about MTI, a short OEM of radio vendor of MTI. Of course, we have a lot of these that we for each of them. Of course, we have a lot of antenna, a lot of solution, different kind of solution, and bottom line, MTI know how to do a good quality antenna. Okay, this is the reason that we are still a major antenna leader in the market. You name it, you're talking about Bicel, you're talking about Cambion, you're talking about Aruba, some of the vendors that was, now very slowly, like Exalt or Proxy, whatever. But Ciclu, you name it. Again, you will find MTI either with the 80 gigahertz or with the flat panel 80 gigahertz or with 5.8 or whatever. MTI, it's a leader antenna vendor worldwide, by the way. We have a huge antenna portfolio for different kind of frequency. And again, we try to position our, we don't want to sell thousands of antenna every day, okay? But we want to sell a good antenna. Of course, we want to do money like everyone, but we think that it's valuable to buy our antenna because once we give you quality, you will get the performance, the required performance from the network. And this is MTI in a short, overview. Of course, you can find in the website all the traffic, all the spec, all the test result, everything. It's free. You can download this. There is no, sign in or whatever information. Everything is open. So I finished my presentation, and let's see if you have any question, please.
Thank you very much, Ofer, for that great presentation. And it looks like we do have a couple questions for you. I'll go ahead and get started here with the first one. Would you say Yagi or flat panel is superior?
Oh, okay, for sure, flat panel it's much better, but Yagi is much cheaper. So in the CPE side, sometimes Yagi is good enough. One of the things that is very hard to find Yagi which have 2x2 or 4x4. So yeah, if you need a single polarity, maybe Yagi will do the job.
Thank you. Next question here for you. Is there a more opportune time to use vertical over a horizontal polarization or vice versa?
Very, very interesting because most of the market is moving now to dual polarization. It's very hard to sell today, to be honest, to sell a single polarity. The main idea that you take VNH is also to increase the capacity. So it means that everyone looking, if you look on our antenna, most of the VNH have the same gain. Regarding getting more coverage, it's complete. Each polarization complete the other one, and also it's kind of backup sometimes. But I don't see any difference from VNH. The main idea that a long time ago they used a different separation between VNH. I mean, either you will use V or either you will use H because interference. But today most of the radio are using at least 2x2 or so VNH. So I don't see any difference between them. Bottom line.
Okay, great. Next question. Does MTI offer link calculation tools to the public?
No, we don't give it. I know that there is a lot of company like Radwin, Cambion, maybe Ubiquiti are giving this. I heard it's a little bit tricky because they are putting their radio and antenna inside, and sometimes they are more of, it's kind of certification, but I understand that it's a kind of tricky certification that the main idea is to buy more equipment. But again, we don't give a link budget, but there is a lot of external tool that you can put the radio parameter in the antenna and you can do the link budget. I think there is few free link budget like this.
Thank you. I have another question here for you. what is the advantage of using dual slant antenna instead of regular dual polarization antenna?
Oh, yeah. Uh, Again, the dual slant, it's a buzzword which comes from the mobility. Okay, there is some or maybe it's approved, but most of the mobile company that are using today, they're using dual slant. If you need a mobility, okay, it seems like the dual slant will work much more better, okay, for mobility. So this is the reason that most of the LTE, everyone is, you can see it's dual slant. But if it's a sector of, sorry, a fixed CPE, you don't need to move, or you don't have any, it's a fixed antenna in the other side. So it doesn't change anything. The only thing that we are using today, the dual slant or the dual pole, it depends on the radio, and also in order to increase the capacity. It means that if we have 4x4, for sure you will have 4x4. You don't have 4V or 4H or 2V to H. It might be that you will find 2V to H, but mostly you will find dual slant and dual slant, sorry, in dual polarization, in order to give you a best separation between the streaming. So today I don't see any difference. It depends on the technology that the radio vendor came with, and I don't see any difference with this.
Thank you, Ofer. A couple more questions here. Next one. What is the best benefit customers can get from using your products, your antennas, as compared to your competitors?
First of all, they got the certification from MTI. Again, I don't look. There is a lot of antenna vendor outside in the market. Okay, what I try to say that to choose the cheapest one or the lowest cost one, it might be good enough. Okay, but you need to see again the antenna parameter. You need to compare. Okay, so I can tell you honestly that. Let's say when we talk about parameter, it seems like that each parameter works separately. No, but if you look on the picture like a puzzle, each parameter is a part of the performance. Okay, so the front to back ratio and the side lobe and the cross polarization and port to port and everything. It's the gain, by the way, the frequency, everything. It's like a puzzle. Okay, so if you took antenna that has a better parameter in each of the in each of the spectrum, you will get much better performance. Okay, but maybe if you take another antenna and the gain is typical, and it's okay sometimes. Okay, but again, the difference between MTI and other vendor that we know, we are the designer, by the way, of our antenna. Okay, there is a lot of company that do the design, and the production it's outside. We do the design, we do the production in-house, all the testing and QA it's in-house. So it means that we keep all the process from design up to production and shipment from MTI. I know that I'm sure that you know that there are some vendors that are doing the design and all the production. It's also from cost of money. Our manufacturer in India, by the way, they do the production. It's on 100% by MTI. So we have all the control from design, purchasing, manufacturing, testing, QA, all the way it's MTI. So I think it's give us some benefit to other vendor that they do the design, but the production is somewhere, and they got it like we call it ODM. They define the requirement, and they get whatever they get. So this is the difference between MTI, excluding the quality of materials, the quality of design, and I think of QA. It's much better than other one.
Thank you, Ofer. Last question here. Can you give us an overview a little bit about tech support or customer service support from your company?
In general, there are two main channels that we are using today in the U.S. One of them is distributors, so all the distributors have all the knowledge to support our customer. They are local, like Microcom, but we have more others. And the other things that OEM, which mean radio vendor, they got a direct support from MTI. Between these, you have all the option to go to our website and shoot an email, and you will get an answer by email or by call. One thing which is very important. This is the reason that we put all the information on the website. You know, the spec, the test result, the drawing, everything that's on the website. And one of the things that we need to understand that antenna is kind of a passive component. There is no software. There is no electronic inside. It's the MTBF. It's very high, and the MTBU. It's a very high. So the main idea that it's a passive component which don't need, you don't have a bug, okay? You don't have a software problem or software version or something like that. So either it's work or doesn't work. And this is the reason that we test VSWR, and we're sure once we ship it working from MTI, it will work for 3 years. So there is no really tech support 24 hours a day, okay? But if someone needs something, and we got always email via the web, whatever they are located, whatever they buy the equipment from Microcom or another distributor, they get the service. Either we call them or we give them an email. But there is no issue of tech support. We mean that that you need to call and you have a network is down or something like that. Sorry. So most of the things that's from the radio, not from the antenna. Maybe the cable, but not from the antenna.
Thank you very much, Ofer, for answering those questions. And thanks to everyone for attending today. And if anyone has any further questions, please feel free to contact your sales rep or email us at sales@microcomtech.com. And if you wish to view any of the products mentioned and shown here today, please visit us at www.microcom.us. Please remember this webinar presentation has been recorded and it will be uploaded to our Microcom YouTube channel so you can view it over again. Thank you again, Ofer, for your time today. I appreciate it, and thanks everyone for joining us today. Everybody, have a wonderful day.
Okay, bye-bye.
Thank you.